Every creator, every marketer, every business owner does the same thing. You make something, you test it, you check if it worked, you tweak it, and you try again. Over and over. Whether it's your emails, your ads, your landing page. It's the same loop, and it's slow, and it's boring, and you never run enough tests to actually know what works. What if an AI agent ran that entire loop for you hundreds of times while you slept? That's the idea behind something called Autoresearch. It's an open source project by Andrej Karpathy, one of the most respected people in AI. He built it specifically for training AI models. But the underlying idea has a lot of potential beyond that. Since it launched, people have been throwing around all kinds of use cases. Optimize your emails, your ads, your trading strategies, your landing pages. Some of them are legit, some of them are not. I'm going to walk you through what auto research is, how it actually works under the hood, why the idea matters even if you're not training AI models. Then we will go through all the use cases people are talking about and see which ones actually hold up. Let's start from the beginning. To understand auto research, you need to understand the problem it solves. And it's actually pretty simple. When someone trains an AI model, here's what it looks like. They write some code that defines how the model runs. You run it, you wait for it to complete, then you check a score that tells you how well the model is doing. If the score got better, great, you keep that change. If it got worse, you undo it and try something else. Then you do it again and again and again, hundreds of times. Each time you are tweaking a setting, changing a number, trying a different approach. It's tedious work, and honestly, most of the time you are just guessing what might work next. What Karpathy did was simple but powerful. He said, what if I let an AI agent do this entire process? Give it the code, tell it what score to optimize, and let it run experiments on its own. It reads the code, comes up with an idea for what to change, make the change, runs the training, checks the score, and if things improved, it saves the change. If not, it undoes it. Then it moves to the next idea automatically, over and over. He called it auto research, and in the first test, it ran 126 experiments overnight with zero human involvement and improved the model by 11%. Here's how it works. There are two parts. One powerful AI model like Claude, that's the brain. It reads the code, thinks about what to change, and writes the modifications. Then on your machine, the actual training runs. The AI makes a change and your computer tests it. And the result goes back to the AI so that it can decide what to try next. The whole system is just three files. Prepare.py sets up the data. You run it once and never touch it again. Train.py is the actual code that trains the model. This is what AI agent modifies every experiment. And program.md is the instruction file. This is the most important one. It tells the AI what to focus on, what score to improve, and what rules to follow. Let me show you what this actually looks like when it runs, and I'll keep it simple. Let's say your code runs through three experiments. In experiment 1, the agent reads its instructions in program.md. It looks at training code and it comes up with an idea. What if I change the learning rate from a fixed number to one that gradually decreases over time? It makes that change, runs the training in 5 minutes, and checks the score. And let's say the score went from 0.997 to 0.993. Lower is better in this case. So that's an improvement. The agent saves that change and moves on. In experiment 2, the agent looks at the code again and thinks, what if I add something called dropout? It makes the change, runs training, checks the score, and this time, let's say the score got worse. So the agent undoes the change completely. The code snaps back to where it was, and it logs what happened so it doesn't try the same thing again. In experiment 3, the agent tries increasing the number of attention heads in the model, basically giving the model more ways to look at the data simultaneously. Training runs and the score drops significantly, and it's saved. That's 3 experiments in about 15 minutes, and the agent did all of this on its own, reading its own history, forming ideas, learning from what did not work. Now imagine that running all night. You go to sleep, you wake up, and there are 82 completed experiments with a full log of everything that was tried. And that's auto research. Now here's where it gets interesting. Auto research was built for AI model training. But if you look at what's actually happening underneath, it's a very simple loop. Read the instructions, come up with an idea, make a change, test it, measure the result. If it's better, keep it. If it's worse, then throw it away, and then repeat the entire cycle. That's not specific to AI training. That's how you improve on anything. And the moment people realized that, the ideas started flying. And that's where we need to be careful. because some of these actually work and some of them really don't. Before we go through the use cases, I want to give you a simple checklist. 6 questions. The more of these your use case can answer yes to, the better this pattern fits. 1. Can you measure the success with a single number? For example, open rate, profit, click through rate. If you can't boil success down to one number, the loop has nothing to optimize. 2. Can you run experiments and get results back? And the faster, the better. A trading backtest takes seconds, a cold email test takes a few hours, and both work. But if you need to wait months for a test, this approach becomes impractical. 3. Can you run a lot of them? One experiment tells you nothing. You need dozens at minimum and ideally hundreds. The magic is in the volume. 4. What happens when an experiment fails? In Autoresearch, a failed experiment just gets undone, though you still need to pay for the GPUs. But if a failed experiment in your use case means losing customers or real money, that's a problem. 5. Is your measuring stick consistent? You need to be comparing apples to apples. Historical price data does not change between tests. A large email list gives you roughly similar segments. If the thing you're testing against keeps shifting, your results are noise. 6. Is the result a number and not a feeling? For example, open rate is a number, Sharpe ratio is a number. But a question like, does this design feel right? Is not. The loop needs something a machine can evaluate without human judgment. Keep those 6 questions in mind because now we are going to use them. Alright, let's go through the use cases everyone has been talking about. I've sorted them into 3 tiers based on how well they fit the pattern. Tier 1. This works great. These are the use cases where the loop runs fast, costs almost nothing, and everything is measured objectively. There are 3 use cases in this tier: trading strategy backtesting, code performance benchmarking, and compiler optimization. Trading strategy backtesting is the strongest fit outside of machine learning. Here's how it works. You write a trading strategy, rules for when to buy and sell. The AI agent tweaks those rules, runs them against 2 years of real historical price data, then checks the Sharpe ratio, which is basically a score for how good the returns are relative to the risk. Each test runs in seconds, and you can do thousands overnight. And since you are testing against historical data, a bad strategy costs you nothing. It's all simulated. It passes every single one of our 6 conditions. Code performance benchmarking works the same way. The metric can be execution speed. The agent modifies code, runs benchmarks in seconds, keeps what's faster and reverts what's slower. Same loop, same principles. Tier 2. It works but with trade-offs. These are the use cases where the pattern genuinely works but the experiment loop is slower because you are testing against real people instead of historical data. This includes cold email, ad copy, YouTube titles, newsletters, product descriptions, chatbot scripts, and more. Cold email optimization is a good example. Your metric is open rate. Clear, objective, measured automatically by your email platform. The agent writes an email variant. You send it to a batch of 300 people. Wait a few hours for the opens to come and feed that result back. If it did better, keep it. If not, then try something different. The agent can improve everything: the subject line, opening hook, the tone, the length, the call to action. It's not just tweaking structure. It's optimizing the actual copy based on what real humans respond to. The trade-off is speed. Instead of hundreds of experiments per night, you are looking at a few per day, maybe 20 or 30 per week. Ad copy and creatives work the same way if you have the budget. Your metric can be click-through rate or cost per acquisition. The AI writes ad variants, you approve them, run them, and measure results after enough impressions come in. Each experiment costs real ad spend. YouTube titles, newsletter subject lines, and product descriptions all follow the same pattern. If you have the volume, enough subscribers, enough uploads, enough traffic, you can run the loop against real-world metrics. It's slower, but the data is real. Tier 3. This doesn't work. These are the use cases where the pattern fundamentally breaks down, not because the loop is slow, but because core conditions can't be met at all. SEO optimization. The feedback takes weeks to months. Google's algorithm changes under review, so there is no stable baseline to test against, and rankings are influenced by hundreds of factors. You can't run a meaningful experiment loop on something this slow and this noisy. SaaS pricing. Now this is a big one people get wrong. Yes, revenue is a clear metric, but pricing experiments take months to measure, and a bad pricing change can drive away your entire customer base. Brand design and UX design. There is no objective single metric for this. You can't put a number on brand quality that a machine can evaluate without human judgment. The loop doesn't work without a number. General research and due diligence. A question like, is this research thorough, is multidimensional and subjective. There is no single metric to optimize that. Finance ops and internal productivity. These are too vague. What's the metric? What's the experiment? If you can't define a specific number and a specific test, the loop has nothing to work with. That's auto-research, how it works, the pattern behind it, and which use cases actually hold up when you look at them honestly. If you want to see me actually build one of these systems from scratch, take the pattern, set it up for a real use case, and run it, let me know in the comments which use case you'd want to see. If you found the video useful, don't forget to like and subscribe the channel. I'll see you in the next one.